welcome to the good life.
The wait is over.
Liftoff of mission 41B, the first flight of the orbital Discovery, and the shuttle has cleared the tower. Every core computers now have primary control of critical vehicle functions.
gonna be there. Alright. Good stuff. Okay, so
This works? Hello?
check.
Mic check. Wonderful.
Okay, so do a quick introduction, and then get going.
We're in? I'm just assuming he's gonna give a count off or something. This would be really cringe. If you look at the inputs, I can tap on this, then you can just see. Hello, hi, hello. I'm on my side, so. Sounds great? Okay, wonderful, wonderful, wonderful. Is the scene changed, or are you gonna give me a count off? Okay. Well, I think I'm ready. Let me on. You good?
Yes.
Things have changed? Okay, we're good? All right. Hello, everyone. My name is Jonathan. We're going to begin our presentation. Oh no, what happened? Go back. Oh no, we're failing already.
There you go. Good stuff. You can go. Right.
Okay, wonderful. Hello, I'm Jonathan. I'm a senior member at the MDC Robotics Club. Today, we're going to be talking about programming LEGO Mindstorms robots. So last week, we went over building and designing robots. We have a few little test models that we have to show off. These will be programmed over the course of the next few weeks as a sort of tool to teach people how to program and how to design and use the engineering design cycle. Today specifically, we're going to be talking about programming, however. So without further ado, let's begin. What is computer programming, right? Computer programming is a tool to tell machines what to do. It's a set of instructions, and these instructions are followed exactly by the robots. So as programmers, we must give our machines very precise instructions. According to Donald Knuth, who is the author of The Art of Computer Programming, he said that computers are good at following instructions, but not at reading our minds, right? And what this means is that when we want to do something, we don't really think too much into it. Let's say I wanted to pick up a robot or pick up something. It's very intuitive for us just to do the motions and pick up whatever we're doing. However, for a robot, the robot has to think about different methods, and we have to program these things. We have to control, let's say, a robotic arm to pick up something. We have to control it moving forward, opening its arm, closing it, moving around, all these different types of things. So even though we want the robot to do everything that we want it to do, it might not happen unless we give it the proper instructions. We program it properly. So how do we give good robot instructions? Usually we have to think about every step along the way, okay? And there's different ways of visualizing this. This is a very basic model of a sequence of different tasks between different objects. So here we have a person who's the end user. He wants to go to a movie theater to buy a ticket to watch his favorite movie. Let's say it's like Morbius, right? We're going to insert a card. We're going to select the date that we want to pick up. And what is the theater going to do? We're going to go down in sequential order. It's going to say, hey, there's dates, there's movies. Let's give this guy a seat, right? This guy sees the new seat. What does he do? He says, I want to see this movie. He submits an order. The theater sees that he submits the order, and it goes to the server. The payment is processed, and then he gets back his seat, right? And this is a very basic diagram of the different steps that you would take, right? If we had another thing, like a robot, we might give it some instructions based on a sensor. The sensor sees something, the robot reacts accordingly. We'll talk about that more in a bit. There's also another type of sequencing sort of diagram, and this involves loops. Loops are very important in programming because we would have to type the same thing over and over and over again if we wanted to achieve some conditions, right? So that's what loops are for. Loops are a repeated subclass of code. You put like some code inside of it, and it repeats over and over again until an end condition is met. Usually we have the for loops, the while loop, and inside of that we have special statements like if or any other sort of logical operators. Here we have this diagram where we start, there's some sort of condition, let's say if there's someone on the website, then it goes through a different program, right? And that thing might be to advertise some sort of product or to do some sort of response, right? And until that condition is met false, so let's say the guy clicks off the website, then the loop ends. And the idea here is that we want to create things with iteration. So between the first and the second iteration, there could be different changes, and over time those changes may result in something new. So that is the basis of the loop. And within loops, we can actually nest other loops inside of them. So for the basic program that we're running right now, we have these Lego Mindstorms blocks, which have very simple logical operators. So what we have here is it says it will repeat until, and then we have two if statements. These are like yes or no, some condition is met, some condition is not met. And this gives us a very basic tree of logic. So nested describes code that is contained within the code of a broader function. The if statement, as aforementioned, is the basis of logic which we'll be using in all these programs. And here we have it. We could also use a if-else statement here, but for the time being, let's say there's some condition, right? If the sensor sees that the light is reflected, we do one thing. If we see that the light is not properly reflected, we do another thing. And this keeps on going on and on until we say for the robot to stop. So what are the parameters for our project, right? We discussed last week that we have a robot with 2 wheels and 1 sensor. And what this means is that we have 2 outputs and 1 input. The sensor is our input, it's the eyes of the machine, and it is all the data that we are given in order to do our problem. Our outputs are the 2 wheels because they also work in tandem. You need different wheel powers in order to turn and to manipulate the machine on the floor. So as programmers, I give us the challenge of thinking about in what ways must this robot turn and what stimuli will it need to turn in order to get the right path. We're trying to follow a path here, so we have to think about the different methods in order to get there. So I went through the trouble of looking at the Mindstorms program. We're going to end up using them on the computers over there. We'll plug them the computers, the little robots. And I went over and I looked at a few blocks that will probably be of big use, right? So we have our repeat until. This is a for or a while loop, and it just keeps going on until the end of time or some condition is met. We have the start motor, set motor speed. This gives us the ability to drive and the ability to turn by manipulating the different speeds in comparison to each other, and the stop motor. On top of that, we have our own little bit of logic, which would be the if statement here. If the reflected light intensity of the sensor is this much, then something will happen, and if it's not that much, something else will happen. And that is the basis of our project today, and that's what we're going to be talking about. It's going to be programming. It's going to be a messy process. I promise that you're probably going to get a lot of things wrong, but that's kind of the fun of the whole process of learning. So that is the end of my presentation on programming with LEGO Mindstorms.
Perfect. Nice.
Yay.
All right. So.
Poggers in chat.
Any poggers?
Poggers in chat. All right.
No bugs, please.
No, Pog is banned. They got rid of Pog.
Nice.
No, it's Komodo hype.
Today, guys, I know you guys